Okay. So, balikan natin yung equation ng deformation. Deformation is equivalent to PL over AE class. No? Okay, so let us discuss the unit analysis. Okay, so this is the change in length. So, obviously, the unit for the total deformation is in as a measure of length. So, since hindi naman ganun ka-exage yung deformation ng structure class, so kagaya nga ng nakikita nyo, yung mga existing structure, meron yung deformation kasi loaded sila. Pero hindi siya noticeable. No? So, unlike ng rubber band, kapag in-stretch mo, excessive yung deformation niya. So, in reality, sa civil engineering structures, the deformation is almost unnoticeable. Kapag noticeable na ang deformation class, so, ano na dyan yung safety, questionable na ang safety ng structure kapag kitang-kita mo yung deformation. So, let's say, nagsag yung beam or nagkaroon ng excessive na deformation, yung nag-lengthen kung ano man yung kinukonsider mong structural member. Let's say, for example, sa trusses, meron kang suspended na member or any steel structure, may suspended na member, nakikita mo talagang noticeable na yung deformation niya. So, questionable na yung safety. No? Okay. So, let us consider this as a measure of length. So, it is in millimeter. No? So, pag in-express mo to sa meter, 0.00 something ka na. So, that's why, usually, nire-require ko ang students, it is in millimeter. No? In English unit, inch. Then, P is in Newton. No? So, if you are going to substitute values or magnitudes dito sa equation, make sure P is in Newton, L is in mm also, no? So, express length in square millimeter, and then area is in square millimeter, kasi usually, maliliit lang din naman yung cross-sectional area, measured in square millimeter or expressed in square millimeter. But the modulus of elasticity is usually 200 gigapascal yan. Ini-express a problem. Then 29 times 10 raised to 6 PSI naman, pound per square inch. So ngayon, ang technique lang dyan class is, let's say, nagsusolve ka na. So ang target mo is to get the value of the deformation in millimeter. You have P, Newton, multiplied by millimeter, yung length, divided by square millimeter, yung A, square millimeter. Now, sa English unit, ang gigapascal is times 10 raised to 9 Newton per square meter, di ba? So, that is, let's say kung 200, edi 200 times 9 Newton per square meter kasi Pascal. This one ay giga kasi 10 raised to 9. Gigapascal. So, kapag cancellation ka, nag-cancel out, squared to, ito ay square meter. So, multiply ka pa ng 1,000 or 10 raised to 3. Di ba? Now, ang ginagawa kong technique dito or strategy na ini-input sa students is that, okay, Newton yung force, millimeter yung length, and then the cross-sectional area is a square millimeter, and then, the modulus of elasticity, pinapa-express ko in megapascal. So, pag in-express mo in megapascal yung 200 gigapascal, that will be equivalent to 200,000 megapascal. So, kaya kapag still yung ginagamit, or 200,000 na to, that is Newton per square millimeter. Kasi, di ba? So, sa last discussion ko sa inyo, kapag ang Newton per square millimeter, yan ay dinidenote na 1 MPa. Megapascal is equivalent to Newton per square millimeter. Kaya pinapa-express ko ngayon yung modulus of elasticity into megapascal because that is equivalent to Newton per square millimeter. So, automatic, kahit hindi ka na maglagay ng unit pag nagsosolve ka, para mas mabilis, although alam mo na dapat kung ano yung units na i-input mo doon sa equation. So, makita mo, square millimeter, cancel, Newton. Newton, matitira mo is in millimeter. Na? Okay, so again, to make it simple, P in Newton, length in millimeter, area in square millimeter, E in megapascal. Na? Gagawin nyo lang naman mga times 1,000 lang naman kayo para maging megapascal. Yung 200 gigapascal, that is equivalent to 200,000 megapascal. Substitute nyo lang dito sa E. Na? Or, so this is to strategize lang naman to make it simple, but still, kung ano yung more convenient sa inyo, kung gusto nyo to gawing meter, ito meter, tas ito naka-gigapascal, no problem naman doon. Saka ano na lang kayo, basta ang final answer kung ano yung nire-require sa problem. If sinabing mm, kung meter, meter, but usually it is in millimeter. Kasi hindi naman ganun kalaki ang deformation when it comes to CE structure problems sa axial deformation. Okay, so yun yung unit analysis. Same with English unit. Kapag English unit naman, P in pounds, length in inch, or inches, then this is square inches, then this one is pound per square inch, kasi PSI. So, cancel yung pounds, matitira yung inch. So, ganun lang yung class. Okay, let us proceed to a sample problem here. I have a sample problem here. Problem number 1. Okay, the problem is, compute the total elongation caused by an axial load of 100 kilonewton applied to a flat bar 20 millimeter thick, tapering from a width of 120 mm to 40 mm in length of 10 meters. Okay, so let us figure out muna the problem. So visualize the problem. So the property of the member is compute the total elongation caused by an axial load of 100 kilonewton applied to a flat bar of 20 millimeter thick, tapering from a width of 120 mm to 40 mm in length of 10 meters. Okay, so i-figure out natin yung member. Okay, so the total length is 10 meters. Tapos, hindi uniform ang cross-section kasi 20 mm thick. Okay, uniform yung thickness, but the width is from width of 120 mm to 40 mm in length. Okay, so consider natin something like this. The figure is something like this, class. Oh, sorry, can't draw it perfectly. Okay, so hindi siya uniform, anak. Okay, the width. Okay, exaggerate lang natin. Something like this. Okay, let's say 40 mm dito ang width dito sa end na to. And then dun sa other end, ang width is, how much? The width is 120 mm. Then, the applied load is 100 kilonewton. So, meron kang 100 kilonewton. Same with here, tensile, subjected to tensile force daw na 100 kilonewton. Okay, 100 kilonewton. So, mapapansin nyo, hindi uniform ang cross-section. Diba? So, yung equation natin na PL over AE lang ay hindi applicable. So, ang applicable dito, class, is total elongation is equivalent to the integral of P at point X mula sa other end times or multiplied by the length over A as a function of X multiplied by the modulus of elasticity. Okay, in this situation, class, so since dito ay maliit, palaki, so pag nag-cut ka at any section, hindi pare-pareho. Ngayon, kukuha tayo ng element. Na, when I say element, application to class ng calculus. So, we are going to get or to consider an element na muna. So, consider tayo ng element, ito lang, na, itong segment na to. Okay, so we have Okay. Then, ibukod natin siya. Something like this. That will be something like this. Na? Yung portion na yon. And then, magkakaroon niya ng elongation. Na? That will be the delta or the elongation of that element. Na? Ang konsepto kasi ng calculus class is that mag-consider ka ng element, isa-sum up mo yung kada element, so makukuha mo yung total elongation. Ano? So, this is the delta for the element only. So, let us denote this as d delta. So, this is the d delta. Ito ay yung total length. So, for this element, this is dx. Na? Okay, so wala namang ibang na-encounter na force. So, therefore, the internal force at dito sa element na ito is still 100 kilonewton. Na? 100 kilonewton pa din. Now, yung P is constant. Na? So, we have 100 kilonewton. Okay, so if we are going to substitute, meron tayong P at a distance x from here. Na? So, yung px kasi, ibig sabihin, the p at x distance mula dito sa end na to. So, let us consider this as x. Kinukonsider lang natin class itong element na to ha. Kasi, kukunin natin yung ito. Kinukonsider natin siyang length dx, tapos d delta d of delta. So, ibig sabihin, yan lang yung deformation nitong segment na ito or nitong element na ito. So, ano pa yung mga kailangan natin? So, we have P. Ang L natin dito class is dx. Area is the cross-sectional area. So, now, let us get the cross-sectional area at this point. Na? Okay, so, assume naman na natin to na uniform yung tawag dito. The cross-sectional area dito sa within the element na kino-consider natin. Now, what is the cross-sectional area? The thickness is 20. Okay. So, A, area natin is equivalent to the thickness multiplied by, pag nag-cut ka kasi dito, kakat mo yan dito, ano yung cross-sectional area dyan? Siyempre, thickness multiplied by the width. Itong width na to. This one. Okay. So, since consider tayo ng broken line here, yung gitna, assume nyo na lang class yung figure ko, Okay, kasi ang hirap mag-draw using the tab, pen tab. Okay. So, let us consider this distance as y. Okay. Consider this as y. Ito. Itong length na to. So, let us consider this as y. And then, obviously, the width daw kasi varies from 42 or from 120 to 40 mm. So, ibig sabihin, itong kalahati nito is 60 mm. And then, sa kabila is, ang kalahati is 20. So, this will be equivalent to 20 mm. Na? Okay. So, meaning, the cross-sectional area is 20, the thickness, multiplied by 2y. Kasi, ito yung total width. Then, multiplied by the thickness, that is the cross-sectional area. Na? Rectangular ang cross-sectional area niya. Okay. A, we have y. Na? In terms of y. So, A should be as a function of x. Na? So, we need to derive an equation showing the relationship between y and x. Na? Ito yung y, ito yung x. Take note that x is the distance mula dun sa another end to the element that na kinoconsider mo. Let's say ito. Na? Okay, so the relationship of x and y from geometry, we have, by similar triangle, we have y minus 20. Y minus 20 class is kapag nag-consider tayo nitong triangle na ito. Magagawa kong line dito. Okay, if we are going to, by ratio and proportion, considering similar triangle here, this vertical distance is y minus 20, right? So, y minus 20 divided by x is equivalent to, this vertical distance is equivalent to 60 less 20. Diba? 60 minus 20. Okay, 60 minus 20 all over, okay, the total length, which is equivalent to, what's the total length? The total length is 10 meters. Okay, over 10. Okay, so the numerator is in millimeter, this one is in meter, na? In millimeter. Kasi maka-cancel out lang din naman yung x dito sa baba. Kasi same naman yung units nila. Okay. So we can determine the relationship of y and x as y is equivalent to 4x plus 20. So manipulate nyo lang yung equation. Kasi 60 minus 20 is 40 divided by 10 is 4 multiplied by x, y is 4x plus 20. So, punta naman yun doon. Ano? Okay, so you have y is equal to 4x plus 20 millimeter. Na? Y in millimeter. So, now since we have already the relationship of y and x, we can replace this by 4x plus 20. So, magkakaroon tayo ng, okay, ito magiging area is equal to 20 multiplied by 2 by 4x plus 20. Okay. Simplifying the equation, magkakaroon tayo ng, okay, 40 times 4, that is 160, x plus, okay, so 40 times 20 is 800. Okay, the unit of this equation is square millimeter. Okay, so we have already the value of area. Ito yung i-replace natin dito sa equation. Then, ang pinaman natin is 100 kilonewton. Take note class, ito yung titingnan nyo ha. Kung, using this equation, ito yung kinukonsider natin, yung element lang. Na? Okay, so, therefore, deformation is equivalent to the integral of P is 100 kilonewton or in Newton, that is equal to 100,000. Diba? Or 100 times 10 raised to 3. Okay. So, what is the length? Length that we are going to consider. So, we have L here. So, since ito yung kinukonsider natin, yung element lang, so, meron tayong L, we are going to substitute dx doon sa L. Ito yung length natin. All over the area. The area is 160x plus 800. Okay. So, nandun naman unit natin. This is in square millimeter. Na? Then, the modulus of elasticity is equivalent to 200 gigapascal. Now, for steel. Okay, so kung 200 gigapascal, so we have 200 times 10 raised to 9. Okay, so this is in the unit of the modulus of elasticity is in gigapascal, no? Or pascal kasi may 10 raised to 9 na tayo, Newton per square meter ito. So, makikita naman natin yan mamaya yung unit analysis, no? Okay, so from here, so may Newton ka doon, may Newton dito, Newton, ito square millimeter. Based from the unit analysis or the strategy na binigay ko sa inyo, pwede natin itong gawin as 210 or 200,000 na lang para siya ay naka-Newton per square millimeter. Kasi ito namang 100,000 natin is in Newton, tapos ito is in square millimeter, then express na lang natin yung E as 200,000 or 200 times 200,000. So, wag kayong magtaka kung halimbawa, bakit kaya yun naging 200,000 or 200 times 10 raised to 3 lang, gigapascal naman yun. Na? So, wag kayong malito. Na? Okay, gawin lang natin itong 200,000. Diniscuss ko earlier kung bakit. Okay, so let us consider this as use 200,000. Na? Okay, so we can, yung mga constant, labas na natin. We have 100,000 over 200,000. That is equivalent to how much? That is 1/2. 1/2 integral of dx over 160x plus 800. Okay, review ng calculus, makikita mo, nasa form ka ng du over u, right? Review lang to ng calculus. Kapag du over u kasi, ang u mo is 160x plus 800, what is du? Du is 160 dx, di ba? Kasi constant, 0 naman na to. So, kailangan mo ngayon ng neutralizing factor. Na? So, magkakaroon tayo ng neutralizing factor na 1 over 160 kasi ang du mo dito is 160 dx, di ba? So, magkakaroon tayo ng, para neutralize lang din siya, magkakaroon tayo ng 1 over 2 times 160 integral of 160 dx all over 160x plus 800. Na? So, yan. Kasi, ito na yung u mo, yung denominator, which is, ang du naman niya is 160 dx. So, ito yung original form natin. Since wala naman talaga dyan 160, kaya meron tayong 160 rin dito sa baba, neutralizing factor. Nagre-review tayo class. Ano? Calculus. Okay. So, since you have already in this form sa calculus, pwede na nating i-write siya as LNU. Na? So, ibig sabihin, the deformation will be equal to, dito na tayo sa baba. Okay. The total deformation will be equal to 1 over 320 multiplied by ln 160x plus 800. Sorry, hindi ko nalagay yung limit. The limit is from 0 to 10. Kasi, y from 0 to 10, nag-consider lang tayo ng elements. So, yan class, yung length na 10 meters is composing of different elements. Ano? So, pag i-consider mo na yung the whole member, so, ibig sabihin, magsasum up ka na lang. No? And the limit is from 0 to 10. 0 to 10. Hindi ko nalagay kanina. Limit is from 0 to 10. Okay? So, 0 to 10. Manipulating the equation, we have 1 over 320 multiplied by ln. Multiply mo lang yung upper limit sa x, then minus, substitute mo yung sa lower limit. Ano? So, that will be equal to how much? Okay? So, that will be equal to ln. Okay. ln of, since 10 yung upper limit, so you have 16 plus 800, that is 2,400 less ln of 1,600. Okay. ln of 1,600. ln 24 minus ln of 16. Okay. Tama ba? ln 2,400, 1,600 plus 800 ln answer minus ln ng 800. Okay. Sorry. This is not 1,600 kasi 0 na nga yung x. So, ito lang pala yun. Na? Okay, so that is equivalent to ln of 800. 800. Sorry. So, ln of 800. So, now, the final answer will be equal to, or will be equivalent to, so yung dx natin is in meter, that is equivalent to 3.43 times 10 raised to negative 3 meter. Kasi take note class, yung dx natin kanina is in meter, ang dx natin is in meter, and then, because x is in meter kasi, now, doon sa unit analysis na ginawa natin, yung 200,000 dito is Newton per square millimeter, tapos ito naman naka-square millimeter, kaya matitira dito Newton, may Newton tayo sa taas, so matitira yung unit ng dx, which is in meter. So this is the final answer, or to express it in millimeter, this is equivalent to 3.43 mm. So these are the final answer. Okay, this is the final answer for the problem. Na? So, application of this equation, considering na hindi uniform yung cross-sectional area. Okay.